Okay, we're going to take a look at solving a linear system by the addition method. So as we see here, this is our linear system. Linear system is an equation of two lines. This example is going to be a very straightforward example in that it already has opposite coefficients. We see here that plus 3y and negative 3y, they are terms that have opposite coefficients of 3 and negative 3. Okay, so as we go through our list of steps here, we're going to first multiply one or both sides, one or both equations by a constant to create opposite coefficients. Well, we don't need to do that because we already have them, as we just said. So the first thing we will in fact do is add the equations together to eliminate a variable. So we'll add straight down and get 6x 3y and negative 3y creates 0, and 12 plus 6 is 18. Then we are going to look at the next step, which is solve for the remaining variable. In this case, it is x, so I'll just simply divide by 6 to get x equals 3. From there, it says plug that value into either one of the original equations. I think I will take the top equation here and take my x equals 3. So we're going to take x equals 3 and plug it into the top equation. So we're going to get 2 times x, which is 3, plus 3y equals 12. And then intuitively we should see that we should solve for the other variable, which I'll do by simplifying 2 times 3, rewriting the rest of my line. Then I will in fact subtract 6, which will give me 3y equals 6. And then I will in fact divide by 3 and get y equals 2. Then my last step here is to write the answers in ordered pair. So I see here that my x is 3, my y is 2, so that would give me 3 comma 2 for my answer. Now, the problem is now done. You could check it. That would make a lot of sense to do on your graphing calculator. You could check it by hand by plugging these values back in. But the one connection I think is important to make is a graphical one. So what I'm going to do is I'm going to clear these out here, my steps, and we're going to take a look at the graph of these real quickly. So if we notice here, if I were to take the top equation and put y equals mx plus b form, I would get this equation. And if I did that similarly for the bottom equation, I would get this equation. Well, when I graph those, I get this picture, and 3 comma 2 is in fact right here, which is the point of intersection. So we see that in fact 3 comma 2 is the solution of the linear system. It is the point of intersection.